Let us discuss ionic equilibrium subjective numerical. Calculate the accurate pH of 5 into 10 power minus 6 molar pyridine solution, Kb of pyridine 1.5 into 10 power minus 9. Now we will take pyridine. This let us dissolve in water. Pyridine act as a base because Kb is given. So nitrogen donating lone pair to this hydrogen, this bond pair is shifting to oxygen. So we are getting pyridinium ion. Here nitrogen has positive charge and OH minus will get. So on dissolving pyridine in water, the resultant solution is having OH minus, therefore it is basic solution, so that Kb is given. Now we have to find pH of the solution. To find pH of the solution, we need H plus concentration. H plus concentration we can get from this OH minus concentration. So we want this OH minus concentration, for which pyridine concentration is given, that is how much means 5 into 10 power minus 6 molar is given. So what is the concentration of OH minus, for which we have to see the Kb. Kb is 1.5 into 10 power minus 9. This indicates this pyridine is a weak base. So it will not react completely. So it will react partially. So how much it is reacting, based on that OH minus concentration will be there. So we have to find it that. So let us consider pyridine reacts X molar. How much pyridine remaining at equilibrium? At equilibrium, that is 5 into 10 to the power of minus 6 minus X molar is remaining. Pyridinium ion is produced X molar, OH minus is produced X molar. On finding X, we can find a concentration of H plus. From that we can go for a pH, we can go. So now how to find a pH for this, that we will see. Now first we will find concentration of OH minus. For that we will go for Kb. So we are going for Kb expression. Kb equal to right side pyridinium ion H plus, that means OH minus, by equilibrium concentration of pyridine. We are substituting Kb. Kb is how much in the sense 1.5 into 10 to the power of minus 9. Pyridinium ion is X, OH minus is X. Pyridine equilibrium concentration is 5 into 10 to the power of minus 6 minus X. X is negligible to 5 into 10 power minus 6. Why? Because it is 10 power minus 9 and also it is very less. Therefore, X is negligible to this. So which is equal to X square by 5 into 10 to the power of minus 6. So from this we can calculate X. X is equal to concentration of OH minus, that is equal to 0.866 into 10 to the power of minus 7. So we calculated concentration of OH minus, we have calculated. Now we will go for concentration of H plus. So Kw is equal to concentration of H plus into concentration of OH minus. So we will substitute Kw is 10 power minus 14 at 25 degrees Celsius. We want concentration of H plus. We will substitute concentration of OH minus, that is 0.866 into 10 to the power of minus 7. From this we will calculate concentration of H plus, that is equal to 10 power minus 14 by 0.866 into 10 to the power of minus 7, which is equal to 10 power minus 7 by 0.866. From this we will go for pH. pH is equal to how much in the sense minus log of concentration of H plus. Let us substitute H plus concentration. Minus log of H plus is 10 power minus 7 by 0.866. Therefore, we are getting a minus log of 10 power minus 7, then plus log of 0.866, which is equal to 7 plus this on simplification we are getting 7. Now we will take a 0.866 log, we will find it. Now we will substitute log 0.866, we will substitute, that is 1 bar 0.9375. So this on simplification comes 6.9375. So pH we got it. So what is the pH of this solution in the sense 6.9375, that means less than 7. Less than 7 in the sense, will it be a base? But it is a basic solution. No, Kb is given means it is a basic solution. No, so it is basic solution, but pH comes less than 7 in the sense we have committed a mistake. What is the mistake here? That means here pyridine is weak base, and the initial concentration is very less. Kb is 10 power minus 9 in the sense pyridine is dissociating to, pyridine is reacting to very much less extent and producing very much less concentration of OH minus. Under this situation, you see in this solution what is there? Water also present. Water present in the sense water also will be in equilibrium. That equilibrium is water gives H plus and OH minus. Water also giving OH minus. Water also giving OH minus in the sense in the resultant solution, in the pyridine solution, water contributing OH minus also there. That OH minus also we must consider. We have to actually pyridine solution contains this equilibrium and this equilibrium. Pyridine is contributing OH minus, water also contributing OH minus. So what is the concentration of OH minus in the solution? Concentration of OH minus in the solution is nothing but concentration of OH minus contributed by pyridine plus concentration of OH minus contributed by water, isn't it? So pyridine solution, what is the pH? What is the pH of pyridine solution? Means in pyridine solution, what is the concentration of OH minus, that we have to take and we have to find. So in pyridine solution, what is the concentration of OH minus? Pyridine contribution and water contribution, isn't it? Generally, we will not consider water contribution because it is negligible when compared to another substance. But in this case, this water contribution is considerable. It is not negligible when compared to pyridine. That's why we got like that answer. Incorrect answer we got. So what we have to do in this case, in the sense water contribution of OH minus we must consider. So OH minus in the solution is equal to OH minus contribution by pyridine as well as OH minus contribution by water. Both we have to consider. So let us do in this way. We will see like this pyridine solution we are taking. In the pyridine solution, this equilibrium is possible and this equilibrium is possible. Now OH minus in the pyridine solution is we will take sum of these two. We will take now. Okay. So now we have to say that concentration of OH minus in the solution we have to say. So here pyridine is initial concentration is this much. Pyridine is dissociating X molar. Therefore, pyridinium ion produced X molar. Okay. This is called a concentration of OH minus in the solution. Similarly, here water is dissociating to give H plus. This OH minus means it is the concentration of OH minus in the solution. Water is dissociating, suppose Y molar. So it is giving H plus Y molar. Now see that water dissociating to Y molar extent and producing H plus Y molar. Pyridine reacting towards X molar, therefore producing pyridinium ion X molar. Now see what is the concentration of OH minus in the solution. In the pyridine solution, OH minus concentration means that is one value. That value here and here will be same, no? So OH minus in the solution here, OH minus in the solution here, OH minus in the solution in the pyridine solution will be same value. So here and here should be same. So what is the concentration of OH minus in the solution means that is equal to pyridine contribution, that is X, and water contribution, that is Y. Therefore, concentration of OH minus in the solution is X plus Y. Concentration of OH minus in the solution is X plus Y, like that you can see. So now we will take, for this case, equilibrium constant we will take. So equilibrium constant for that is equilibrium constant, that is Kb equal to concentration of pyridinium ion into concentration of H plus ion, that is OH minus ion, not H plus, OH minus ion by concentration of pyridine at equilibrium. Let us substitute this Kb, we will take this concentration, we will take it as X. This concentration we have written as x plus y. This concentration we will take it as a initial concentration C minus x molar is reacted. This x we are neglecting with respect to C, so we will take KBC is equal to x into x plus y. Here we have considered, we have taken the assumption. What is the assumption? In the sense C minus x is nearly equal to C, we have taken. Why? Because otherwise we will get cubic form of expression. That's why we have neglected, and in this sum it is correct of neglecting. Okay, so we got KBC is equal to x into x plus y expression we got. Next equilibrium we will take. What is that equilibrium means? For this equilibrium constant we will take it as ionic product of water, that is Kw we will take. Okay, so Kw is equal to concentration of H plus into concentration of OH minus. So Kw is equal to concentration of H plus is y, concentration of OH minus is x plus y. Let us take it is equation number 1 and it is equation number 2. Let us solve equation 1 and 2. We will solve 1 and 2. On solving 1 and 2, we will get x plus y. That x plus y is called concentration of OH minus. So we have solved 1 and 2. From 1 and 2, we are getting x plus y. That x plus y is equal to concentration of OH minus. That is equal to square root of KBC plus KW. That is the formula we will get. So from 1 and 2, we will get x plus y. That x plus y is called concentration of OH minus in the solution. That is equal to what means square root of KBC into plus KW. So now we will substitute the values. So we got the formula for concentration of OH minus in the solution. That is how much in the sense square root of KBC plus KW we got. Let us substitute the values. We will substitute Kb. Kb is called base dissociation constant, that is 1.5 into 10 to the power of minus 9. C is called the initial concentration of pyridine, that is 5 into 10 power minus 6. 5 into 10 power minus 6 molar, plus Kw is called ionic product of water. Ionic product of water is 10 power minus 14. 10 power minus 14 it is. Okay. Let us simplify this. We are getting concentration of OH minus in the solution, that is equal to 1.323 into 10 to the power of minus 7 molar. Okay, we got concentration of OH minus in the solution. Next, we will get concentration of H plus in order to find pH. Therefore, we will take Kw expression, Kw equal to H plus into OH minus. Let us substitute Kw, that is 10 power minus 14. Let us find H plus concentration. Let us substitute OH minus, that is 1.323 into 10 to the power of minus 7. So we are getting concentration of H plus, that is equal to 10 to the power of minus 7 by 1.323. We got concentration of H plus. Let us go for pH. The pH formula is pH is equal to minus log of H plus. Let us substitute H plus concentration, that is 10 to the power of minus 7 by 1.323. Now let us simplify. It is equal to minus log of 10 power minus 7 plus log of 1.323. Minus log of 10 power minus 7 is 7 plus log 1.323 is 0.1216. Now let us add, we are getting 7.1216. It is called a pH of a pyridine solution. So for the given question, the accurate pH of pyridine solution is how much in the sense 7.1216.